Hi everybody, this is Julian from Arcee. Small language models are great candidates for local inference. So in this video, I'm going to show you how to run two of our latest open source models, Virtuoso-Lite and Virtuoso-Medium-v2, on a MacBook, and precisely on an M series MacBook. To do this, I'm going to show you two different tools, Llama.cpp and MLX. And I'm going to show you every step, how to install them, how to convert the models, and how to run inference. Okay, so you'll be able to replicate everything. Sounds good? Let's get started. Before we dive into the tools, let's take a really quick look at the two models we're going to work with. So Virtuoso-Lite and Virtuoso-Medium-v2, which we released as open source models about a week ago. So I'll put a link to our blog post. You can read about the models and look at the benchmarks. Of course, I will also add the link to the model pages on Hugging Face so that you can read all about that and grab the models. And what's really cool about those two models is that although they're still small models, Lite is 10B, Medium is 32B, they're way better than much larger models from just a few months ago. And in fact, if we look at the leaderboard, and if you look at models up to 14 billion, you will see that Virtuoso-Lite is the #1 model, outperforming other models under 14B, right? So pretty happy about that. No ranking for Medium V2 yet. That's going to show up, but I wouldn't be surprised if it was very close to the top. Let's see where we end. And we have new models coming all the time, so keep an eye on those. So Virtuoso-Lite, very good choice for 10B and below. So maybe if you're using 8B models today, if you're using Llama 8B or similar size models, I would really recommend that you look at Virtuoso-Lite. It's just a tiny bit bigger, so it would probably still fit in whatever platform you're using today, and it's likely to be a massive upgrade, right? Details in the blog post. Okay, so now let's take a look at the tools we're going to use, and you're probably familiar with them already. So the first one is going to be Llama.cpp, which is a great library to optimize models for inference across a number of platforms. So we're going to set it up, compile it, the whole story. And we're going to work with MLX, and particularly MLX examples, which has the language model support that we need. Okay, so let's jump into a terminal and start installing everything. Before we build the tools, let's go and grab the model. So the easiest way to do this is to use the Hugging Face CLI tool, which you can install like this, right? Okay, pip install Hugging Face Hub, and then you need to log in. Okay, so enter a token from your Hugging Face account. You just need a read-only token. I've already done this, so no need to log in again. And then you can just go Hugging Face CLI download and grab the model name and a local directory. And I've already done this, but for the sake of it, let's just run it again. Okay, let's do the same for the other model. Download, repo, and this one is this. Okay, good. So now I've got the models. Let's go and install our tools. So now let's build our tools. I'm assuming you have a build environment ready, which should be as simple as installing, I guess, make, CMake, and GCC with Homebrew. Okay, so we have all of that, so we should be good. So now let's go and clone Llama.cpp. Okay, and the build is actually pretty simple. This is how I do it. Okay, CMake. What we want is this, right? The metal backend, not that metal, the Apple one. And now we can just go and build it, right? And let's make it fast. Okay, so now we've built it, and we should see all those good tools in bin which we're going to use. So there's one last step to make sure we have all the requirements. Just pip install requirements txt, and this will make sure we have everything we need for the Python tools in Llama, right? Good. Okay, so now we can start working with the models. The first step is to convert the Hugging Face models into GGUF models. So GGUF is the representation that Llama.cpp uses, and it converts everything into a single file, which is obviously easier to work with. So let's run this. It's very simple. You just need to point to your directory, and it's going to do its thing, and that shouldn't take too long. Okay, so it's going to take a few seconds, as you see. So in many cases, you will actually find the GGUF models on the hub. For example, we have this one here in our org, Virtuoso-Lite GGUF. Okay, and you have plenty of versions: 2-bit, 3-bit, 4-bit. We'll get to that. These are quantized versions. So if you find those versions already, great. You don't have to run the conversion, but then again, conversion is very fast, and there's no harm in doing that yourself. So once you have done this, you see that you have this big 16-bit single file version of the model. Okay, so that's good, and I guess we could already run this just to see how fast it is. So if we went llama CLI, no CNV, because we don't want conversational. Let's generate 512 tokens, and let's just prompt something here and use that model. Yeah, this one. Okay. So we're running the 16-bit model, original precision, and well, it's reasonably fast. So well, that's an option, right? If you want the original model, that's a good way to do it, right? And we get about 16 tokens per second, right? So one thing I noticed actually is by default, we're not using all the threads on this machine. So let's see if we can go a little quicker, and you would just say -T16. So, okay, 16 tokens per second. Let's see if this is a tiny bit faster. We're certainly keeping the machine busy here. Does it look faster? I don't know. We're gonna find out. Nah, it's about the same speed. Okay, so we can do 16 tokens per second with the original model, which isn't bad at all. So how can we make this faster? Well, of course, we can go and quantize the model. So let's do this. We'll start from the large model, the 16-bit model, and if we just go like this, we can see all the quantization recipes that are available. Okay, so the one we're gonna try is maybe Q40, which is usually very fast, And I would also recommend, if you want a little more precision, maybe go with Q4KS or Q4KM. Because as discussed when we talked about quantization, obviously when we shrink the size of the model parameters, we do degrade accuracy a little bit. For most use cases, it shouldn't be a problem, but if you see that answers are not as good, you can go and quantize to a slightly less aggressive scheme. Okay, but I'm gonna do Q40. Okay, so let's start that again. Quantize Lite. Okay, Q40. And it's a very, very fast operation, as you can see. Just applying math to the parameters. And we're gonna get another GGUF file. Okay, a much smaller one, of course. Okay, we can see the original one, which is about 20 gigs, which makes sense for a 10 billion model. And we can see Q40 is under 6, and Q4M, which is a little more relaxed, is 6.2. Okay, so now let's just run inference again with this quantized model. 512 tokens, no conversation. And here we go. And we can see this is much, much faster. 47 tokens per second. So we went from 16 to 47. So that's almost 3x, right? That's almost 3x. Let's try and get it to be a little more chatty. Okay, here we go. And we can see, yeah, we are keeping everything pretty busy. And again, 47, right? Llama.cpp also has flash attention, which you can try like this, but sometimes it's a bit faster, sometimes it's not. Not sure why. Let's see if we get some improvements here. And you can see the answers are good, right? I mean, it's not like it's not a poor, unstructured answer. It's still very good. And we get about the same speed. You can run more benchmarking if you want. There's a tool called Llama Bench, which you can try different batch sizes, etc. And if you want to measure model quality, there's a Llama Perplexity tool, which will measure model perplexity, its ability to predict the next token on different data sets. So this takes a while to run, and I've done that. And for Virtuoso-Lite on the Wikitext2 dataset, perplexity, going from 16-bit to 4-bit, perplexity only increases 1%, which is honestly negligible and amazing. It's the best number I've seen so far. So that means you can literally run the 4-bit model with the same precision as the 16-bit model on your local machine, except 3x faster, right? So that's pretty cool, okay? I've done the same thing for the other model. Let's try that as well, and then we'll switch to MLX. Exact same process, no need to show you again. Okay, Q40, bam. Okay, so this one is the 32, we can see it here, 32.7B model. So let's see how fast we're going now. So this model runs at 16 tokens per second, which is same speed we had with the F16 10B model. So, the choice is yours. For the same speed, you can either run a 10 billion model at the original precision, or you can run a much larger model quantized to 4 bits, right? And obviously, if you're just after performance and speed, the 10B model is really, really unbeatable, okay? So let's earmark those numbers. 16 tokens per second for the larger model and 47, 48 for the smaller model, okay? And we're gonna see if we can match or, do better with MLX. MLX itself is a library similar to NumPy to accelerate scientific operations on Apple hardware. Okay, so you can go and look at MLX itself and the repo if you're curious about this. When it comes to working with small language models, the one repo we're interested in is actually this one, MLX example. Installing it is as simple as pip install MLX LM, and it should take care of all the dependencies. Okay, you can use this in different ways. There is a Python API if you want to use that stuff programmatically, and there's also a CLI, which is the one we're gonna use, right? So MLX generate is where you want to start exploring. Okay, it's super simple, as we'll see, and there's a chat. We're gonna try this one too. Okay, so we have what we need. MLX is similar to Llama.cpp in the sense that you need to convert and optimize the models for it. So you can do this with the Python API, as you can see here, or you can do the same thing with the command line. MLX supports quantization; it's built in. What is interesting about MLX is they have a very large community on the Hugging Face Hub, and the community will convert and put a ton of models in that organization. So the benefit for you is you don't have to go and look for GGUF files, which may or may not be there. You can just go to the MLX community organization, and as you can see, they have over 1,400 models converted already, and you can contribute more. You can join the community and push more converted models to this page, which is great, right? So central place to find models, and obviously you'll find a lot of models from us. So if you just go and search for them, I don't know, if you go Virtuoso, yes, we're gonna find everything we need. Virtuoso-Lite 4-bit, there we go. Okay, so perfect. We don't need to convert it. We can just go and run this directly. You can just go and run MLX LM generate. Oh, let's look at the options. Yes, model. Okay, and I guess we need a prompt. And that should be enough. So the model was downloaded. Now we can go and generate some tokens. And this is nice and fast. Okay, yeah, okay. We'll call it we'll call it 51. Which is quite faster. Which is quite faster than Llama.cpp. It was 46, right? Yes, come on. $46, $47, and now we're getting 51. So that's not quite 10%, but close. And that's pretty significant. 10% faster is great. So let's go and try the larger model. See if we get good results as well. Medium-v2 4-bit, I think is the name. Okay, and this one was already downloaded. Okay, so we're at 17 point something. Again, probably 9%, which is always good. Makes a difference at the end of the day. So that's what I wanted to tell you today. I'm a huge fan of local inference for small language models, and both Llama.cpp and MLX deliver that. MLX is a little faster on Mac hardware, probably 8-9%, and I really love the community they have on Hugging Face, which makes it very easy to find models and contribute new models. Llama.cpp is still very good, and of course it runs on many more platforms, not just MacBooks. So the two are equally interesting and you should follow them both. That's it for today, and until next time, you know what to do. Stay metal, Apple metal or metal, and keep rocking.